How's it going, geometry class? Today we're going to be talking about 3-2 properties of parallel lines. Okay, you're going to notice a common theme in the first 4 sections of chapter 3. We're going to be dealing with parallel lines crossed by a transversal. Okay, let's take a look at our first postulate. Take note. Postulate 3.1 states that corresponding angles, or the corresponding angles postulate, if a transversal, remember transversal is a line that crosses 2 lines, intersects 2 parallel lines, then corresponding angles are congruent. Okay, let's take a look at what that means. Remember, our corresponding angles means they're in the same spot, so the angle that corresponds with 1 is going to be in the upper left-hand side, and the angle on your other parallel line that's in the upper left-hand side is 5, right? So if L and M are parallel, if these 2 lines are parallel crossed by our transversal T, then angle 1 has to be congruent to angle 5 because corresponding angles are congruent. Okay, switch of colors. So what about 2 is in our upper right. So down here, our upper right is, well, 6. So we can say 2 is congruent to 6. And that's how we get 3 is congruent to 7, and 4 is congruent to 8. Okay, so we learned what corresponding angles were last lesson. This time we're saying that if those 2 lines are parallel, then corresponding angles are congruent. Okay. Now guys, don't forget, this is a video. Pause it whenever you need more time for notes. Pause it, go back if you have a question, write question mark down your notes, ask me about it tomorrow. Let's do a proof. Okay, so they tell me that A and B are parallel, and I have to prove that 1 is congruent to 7. We're going to probably use that postulate we just learned just because, well, we just learned it. So here we go. Let's do our statements and our reasoning, right? Okay. So first one always, A is parallel to B. And why? Well, it tells us right here, it's given. Okay, that should always be the easy one. I'm actually going to use the line tool. I'll stay with red. Okay. Next one we're going to look at is, well, what can I say about angle 1? Do I know any relationships with angle 1 and any of these guys? Well, the slide before said that my corresponding angles are congruent. So you can say 1 is congruent to 5. And 1's congruent to 5 because, well, corresponding angles here I'm actually going to draw this. On parallel lines are congruent. Okay? Or you could have said corresponding angle postulate. That would have been fine too. Now, I know angle 1, I know what angle 5 is. How can I get from 5 to 7 or from 1 to 7? Well, if we look here, here's 5, here's 7. They make a bow tie. Those are a bow tie, also known as vertical angles. Remember, you don't want that bow tie messy. You want both sides to be congruent. So I think you can say angle 5 is congruent to angle 7 because vertical angles are congruent. Right? Okay. One more step, and this proof is proven. So if 1's equal or congruent to 5, and 5's congruent to 7, if 1 connects to 5, 5 connects to 7, that means we have a transitive property with 1 as our head car, 7 as our caboose. So I can say, get my proof done, 1 is congruent to 7 by, well, our transitive property. Transitive prop of congruence. Okay. Capiche? Any questions, make sure you write them down in your notes. I'll address those before we get started on our homework tomorrow. Alright, next slide. Look at all these theorems. Okay. First theorem is the alternate interior angles theorem. What that says is if parallel lines are crossed by a transversal, the alternate interior angles are congruent. So like 4 and 6 are. So the big thing you gotta remember is what the definitions are. Or what are alternate interior angles? Well, remember, alternate means I have to jump over the line. Interior means I'm inside my parallel lines. And another big piece of advice, if you ever get stuck, you're taking the ACT, you're taking some test, and you say, I completely forgot what all these are called, a good tip is all the little angles are congruent and all the big angles are congruent, okay? And our second one down here is going to be, this one's a little bit trickier. We're going to prove this one. This says that your same side interior, that means you go in your interior and you don't have to jump over any lines. So like these would be same side interior. If you add those up, it equals 180. So they're supplementary. Okay? We're going to prove that by the end of this lesson. So go and pause this if you need to write down. Or some people might like to pause it when they first get to it and then play it and then listen to the lecture. I'll give you guys a second to finish up whatever you're writing. Alright, we're moving on. Here we go. This proof is going to be very similar to one we did before, or kind of similar to the proof to prove that your same side interior add up to 180. Let me get out my line tool. Here's the line. Here's the line. Okay, so again, statements, reasoning. First one I'm going to make is always my given, right? A is parallel to B by given. Okay? Now where do I go? Well, so far the only tool I have for exterior is 1 is going to be congruent to 5. Upper left, upper left. I go angle 1. It's congruent to angle 5. Because thus corresponding angle theorem. Or postulate. Okay? Now where do we go? Okay, so now we gotta come up with a relationship. How are we gonna throw 8 into the mix? So when I look at the picture, I notice that, well, 5 and 8 form a linear pair. And what's it mean when you form a linear pair? What your degree measure is? Well, that tells me that angle 5 and angle 8 are supplementary. And that's because I want to say definition of linear pair. Okay. One more step, guys. So if 1's congruent to 5, 5 and 8 are supplementary, I can take this information and say, well, wherever there's 5, I can plug in a 1, right? So I'm saying angle 1 and angle 8 are supplementary. And that's by substitution. Okay. Prop of congruence. Feel free to pause it. This will probably be one of our longer videos, this chapter, just because there's 2 proofs in it. There's a lot of definitions. Let's go and take your time. I'm actually going to pause it for a second. Alright, 2 more slides, guys. This leads us to our alternate exterior angles theorem. We already proved this on slide 2. What it says is, and again, all of your big angles are equal, are congruent. All your small angles are congruent. If I jump over this line to the other side and stay on the outside, those 2 angles are congruent. So 1's congruent to 7, 2's congruent to 8. So this is our last arrow we're going to put in our quiver today to attack our proofs and attack our homework problems. Okay, so take a second, take that in, think about it, process it. Let's look at the last slide. Oh boy, lots of problems. Okay. Trapezoid. Trapezoid is a quadrilateral with 1 set of parallel lines. Okay. And, well, by using that definition, I can say this top guy and this bottom guy are parallel. They have those arrows on them, which tells me they're parallel. So we're going to use the same side interior angle theorem to complete each statement. So I look over here, and I'm same side. So if you can't see this picture, just imagine this is extended. And then we're just looking at this guy right now. Parallel lines, crossed by transversal, same side interior. They're going to add up to 180 because they're supplementary. So 2x plus x minus 12 equals 180. When we do some algebra, we get 3x minus 12 equals 180. 3x equals 192. Add a 12 to both sides. Divide by 3. Divide by 3. Looks like I'm going to use my handy dandy calculator. So we get x equals 64. Now this one we do the same thing. These 2 are going to add up to equal 180. So 3y plus 20 equals 180. 4y plus 20 is 180. Subtract 20, subtract 20. 4y equals 160. Divide by 4 and you get y equals 40. There you go. Alright guys, make sure you bring questions in. I know we went through a lot of stuff in a short time. Well, any questions I'll not be afraid to answer. Alright, that's the end of the video.